All right, I want to do number 21 and 7.5, and it says to find all solutions, and then it says instead of 6 specific solutions, it asks you to find all the solutions between 0 and 2 pi. So I want to do one of these as well. So the problem is the square root of 3 times the tangent of 3 theta. So this is a multiple of an angle because it's got 3. I've got 3 theta in there. All right, and plus 1 equals 0. So the first thing I'm going to do is isolate my trig function, my tangent of 3 theta. So I'm going to subtract 1 from both sides. So I've got the tangent of 3 theta equals negative 1. Then I'm going to divide by the square root of 3 on both sides. So I've got the tangent of 3 theta equals negative 1 over root 3. And this would be more familiar to you if it looked like, if I rationalized it and looked like the square root of 3 over 3, and it's negative. All right, so let's talk about this. Before I find what theta is, I want to figure out what 3 theta is. So when you have a trig ratio and it's equal to a negative number, I mean, you can go ahead and think about what 2 quadrants your angles would be coming out of since it's negative. If tangent's negative, that means that it's coming from quadrant 2 and quadrant 4, because tangent is positive in quadrants 1 and 3. So 2 and 4 is where I'm getting this solution from. Now, when you're looking for your angles out of quadrants 2 and 4, you want to remember what your reference angle would be. Your reference angle is your acute angle out of the first quadrant, so that's where it's positive. So you're looking for the tangent of 3 theta is the square root of 3 over 3. Well, that reference angle is going to be pi over 6. So that's my reference angle. Now, to find my angles out of quadrants 2 and 4, remember that we're always going from the x-axis. So to find it out of quadrant 2, I'm just going to do pi minus pi over 6, which if I get my common denominator, that's going to be 6 pi over 6 minus pi over 6, which is 5 pi over 6. All right, and then if it asks for all solutions, remember that I am dealing with tangent here. So the period for tangent is pi. So I'm going to add pi times k for all solutions. Now the good thing about that is when I'm dealing with tangent and the period is pi, if I find my angle out of quadrant 2 and I add pi to that, think about that, I'm adding 180 degrees. Well, that is taking care of that angle in quadrant 4 as well. So the good thing about tangent is when you find one solution and you add that pi k to it, you've really taken care of all your solutions. So this is the only solution I need. So at this point right here in my problem, I've got 3 theta equals 5 pi over 6 plus pi k. All right, but we need to take it one more step because I'm not solving for 3 theta, I'm solving for theta. So this last step is going to divide everything by 3. All right, so that's going to give me my theta. So theta in this case is going to equal, now remember 5 pi over 6 divided by 3 or multiplied by 1/3 is going to be 5 pi over 18. So my solution is going to be 5 pi over 18 plus pi over 3, because I divided that by 3, times k. And that's going to take care of all my solutions. All right, and I'm going to go ahead and kind of switch modes here. So if WebAssign, if you're working in WebAssign and it asks for all solutions, like I said earlier in another video, if it's asking for all solutions and you're using the integer k, if you're using k as your integer to represent your integers, you're always going to use radians. It's only going to take radians as your solutions. But if it asks for specific solutions, you can use degrees. Just make sure that you use the degree symbol when you input your answer. Now, if I'm looking at this and I know this is all my solutions, I'm thinking this is 50 degrees plus pi over 3 is 60 degrees K. You see, it's going to be a lot. I could do all this in my head. If I let K equal 0, K equal 1, 2, 3, 4, 5. Let's just see how far we have to go. Remember that on this problem, we're only looking for values between 0 and 2 pi, or 0 and 360, and then we're stopping. So if I let K be 0, for example, well, 50 degrees plus 60 times 0 is 0, so I've got 50 degrees is one of my solutions. If I plug in K to be 1, I get 60 times 1, so 50 degrees plus 60 degrees is 110 degrees. If I plug in 2 for K, I get 120 degrees plus 50, which is 170 degrees. If I plug in 3 for K, I get 180 plus 50, which is 230 degrees. If I plug in 4 for K, I get 240 plus 50, which is 290 degrees. If I plug in 5 for K, I get 300 plus 50, which is 350 degrees. And then notice that if I plugged in 6 for K, I would get 360 plus 50. Well, that wasn't my conditions. My conditions were between 0 and 360. So I only have 6 solutions between 0 and 360. So you could certainly list these in degrees, or if you're just going to stick to radians and not waver from that, let's just do this whole thing in radians so you can see that. All right, if I plug in 0 for K here, I get 5 pi over 18. If I plug in 1 for K, I get 5 pi over 18 plus pi over 3. Now all these, if you do these like that, you're going to have to get a common denominator. So this would be 5 pi over 18 plus 6 pi over 18, which is 11 pi over 18. And you can continue like that. And you're going to get the same answer. So you're going to get 17 pi over 18. You're going to get 23 pi over 18. And then you're going to get 29 pi over 18. And then the last one would be 35 pi over 18. And that would be your 6 solutions between 0 and 2 pi if you're dealing with radians.